All right, everyone. Welcome to UTA Planetarium's another live star stream. First of all, I would like to start with a very important notification. Do not click on any links on the comment section. Unfortunately, I think there is like a common issue on Facebook, as we heard. As we start the live stream, some people are posting comments with a different live star stream look like our live star stream. And because you need to click on too many things on the Facebook to find the live star streams, uh, then you are automatically diverted to a spam website. Most of the time it is asking for like a login information and sometimes credit card information. And please be careful. If you are watching this live star stream and just to make sure you're on the right website, you need to be under Facebook domain. So if you are watching this live star stream from a different website in your browser, then you're in the wrong place. So please do not click on any links. Our team, social media team, is on the look for these type of posts, and they will just do their best to remove those type of activity as soon as they can. But also we need your help to just not click on any links that you see on the live star stream section. So please be careful. All right, today we are going to talk about some fiery balls we see at night, time to time. I have seen on social media last week footages of fiery balls in the skies of Turkey, Russia, and here one in Mansfield. What are they? I have received several questions on social media on what they might be. So currently we are looking at a footage that was seen in Turkey. I believe that it was like a security camera capturing the event. And all of a sudden, in the very early morning hours, there was a big shock in the sky, big flash that caught a lot of eyes. Also, there was one reported in Russia, not at the same time on the same day. It was different event, but very similarly. And you can see some similarities. A pinpoint of light gets really bright in the sky, then immediately turns into a big flash and then disappears. Flash actually is the indication that the meteor is actually breaking into pieces, and it is corresponding to a explosion. And one in Mansfield was also caught in the skies of Texas, and that's some clip that was reported by local news media. Similarly, and this is not spectacular as the other ones, but still it is catching a lot of eyes. So those are the fireballs. First of all, they are very common. There is nothing to worry about them when we see them in the sky. Those are publicly known as shooting stars, but we scientifically call them meteor events. Meteors are, and I have one in my hand right now, and this is a found meteor. We call them meteorite, and we found them in on the surface of our planet. Meteors are rocky debris that fills the space between planets. So there are plenty of those orbiting around the sun between the space between the planets. Planets are constantly moving on their designated orbit and sometimes encounter a space that's full of this. Well, what happens then? By Newton's law, planet exerts gravitational force on each particle in that debris field. Resulting particles accelerate towards the planets. In this case, three things likely to happen. Depending on the initial travel direction of the particle, planet's exerted force may not be sufficient enough to divert the particle towards the planet, and the particle misses the collision. Or particle is diverted to just a right angle that centrifugal force on the particle resulted of this diversion is equal to the planet's gravity force. Then the particle starts orbiting around the planet and becomes its moon. Saturn's rings, for example, every tiny particle forming the ring acts like the moon of Saturn. And here we go, we are looking at the beautiful rings around Saturn. We have one more case scenario, which is that the particle comes on a head-on collision with the planet. We have talked about the moon being under the bombardment of the space debris that creates moon craters. Well, it's fortunate that we are not living on a Mercury or the moon, as this kind of space debris yet to have another challenge before hitting the surface of our planet, and that is air friction. When an object moves on Earth, it encounters a drag force by the air molecules. The faster the object, the greater the drag force. That's why we have aerodynamically designed cars and airplanes that uses as much curves as they could to minimize the drag force. Well, for example, this is a car from 70s with no consideration of any aerodynamic design. It's a little boxy. And here is the new generation car that introduces a lot of curves in the wind front. So the wind actually has a smoother path around the car. So of course that provides a lot of fuel efficiency and economy. Well, you can also experience that wind drag when traveling on a car. Just pull your hand outside and just feel the resistance from the wind. And if you put actually your hand sideways, you will see that the drag force exerted by the wind is going to get less and less. Well, that's not very important on a car speed, but these space trucks are actually falling on Earth at extreme speeds. Well, the drag force actually becomes sufficient enough to burn them and turn the rocks into fireballs. That's why we see fiery balls falling on our planet. Well, meteors are usually small pebble-sized rock pieces. They are very short-lived as they completely burn into ashes just in a second. Ashes still fall on Earth though. Earth gains weight about 15 tons a day from falling space debris. That's about 2 18-wheelers weights a day. However, you may be looking at the sky for hours and not a single meteor you can spot. Well, if this is happening at our line of sight, it may be happening elsewhere. So we need to think that 75% of our planet is covered by water. Meteor events likely be seen from water than the land. Our population is not also dominating the land, as there are large deserts and icy regions that humans don't live. So we only see meteor events when it happens above our cities. And most dim ones are also going unnoticed due to light pollution around our cities. So can they be large? Yes, meteors can be sometimes as large as like a basketball. And if larger, then likely they may end up hitting on our planet in the form of this meteorite. So museums have those meteorites on display. We have 2 of them here at UTA Planetarium, and we are actually looking at the largest found, the meteorite on Earth. So they are varying in size. Well, can they be in a size of a car? Well, that's what we are trying to avoid, right? So we should say that 75% of chance they will end up in water. But there's still 25% of chance the meteors may end up on a land if they are big to start with. If you get a chance to visit Arizona, you should visit the Arizona crater located 37 miles east of Flagstaff. The crater was formed about 50,000 years ago when 160 feet across meteor hit with stunning 29,000 miles per hour speed. The most significant meteor event that we think is responsible for extinction of dinosaurs goes back to 65 million years ago. A new space.com article revealed new findings about the impact that extinct about 75% of species on Earth. Well, according to research, the impact the researchers modeled was for an 11 miles wide meteor to start with, hitting Earth at 27,000 miles per hour at angle of 60 degrees from the horizon. This angle was critical as it exerted 3 times more sulfur and carbon dioxide to the air as originally thought. And that actually set the stage for dinosaurs. The impact location was just across the Gulf of Mexico, near a town called Chicxulub. It's underneath the Yucatan Peninsula, and exerted dust blocked off the sunlight for days, and toxic sulfur and carbon dioxide killed most species on the surface of our planet. That is what 11 miles wide space rock did to our planet. If we compare the size of Earth with 11 miles rock, it is very small, but the impact speed that matters. Today, here we are going to talk about another physics because the energy that comes out during an impact is determined with the momentum law. It's mass times speed. So that means small mass, high speed can produce as much energy as with big mass at low speeds. For example, trains. When a train hits to a brick wall at low speeds, still delivers a destructive amount of energy. Meteors are the opposite way of this. Meteors are small, but still provides destructive energy as their speed is very high. Well, if you see a shooting star or fireball in the sky, now you know exactly what it is. So, should we worry about them? Definitely yes. If a large size space rock is headed to our way, we definitely want to know. NASA has space observatories and ground-based telescopes to track comets and asteroids, and that may be a threat to our planets. NASA was recently watching 5 asteroids, and one actually being the stadium size. None of them was projected to be a threat, and the largest one just missed Earth by 3 millions of miles just past Saturday. So probably we didn't know about this was happening past Saturday, but yes, there was about stadium-sized meteor just passed by Earth and missed by 3 million miles. Now that's about 10 times more than Earth and Moon distance. But if you looked at this event at the solar system map on a table, it looked real close. Well, if you have any questions, let's look at some of the questions you have. And curious about the colorful picture of the car we just showed in the wind tunnel. What was that? I think the first one was a Fiat 124. It was from the 70s. And if I'm not mistaken, the second car The second car was, I believe it was, I cannot tell from how it looks, but I think it was a Mercedes. And isn't square an unusual shape for a meteorite? Yes. Usually we find them in irregular shapes. For example, just like this one, or the one you see on the stream. So it may be broken into pieces, and broken pieces may be in any shape, depending on how they broke. But one thing very common about meteorites we found is one edge is introducing a very smooth curve. If, let's say, we found the meteor is in one piece, one shape should introduce a very smooth curve with a lot of burn marks. So that will probably is a good indication for that it fell from sky. But if you are not seeing any burn marks or any smooth surface, that can still be a meteorite, because it can be pieces of a big meteorite. So yeah, that can be in any question. It's but the complete piece, if we found it, is not going to be having a very certain shapes. Let's see if there are any other questions, and if you come up with some question later, you can also drop the comments to us, so we will get them answered later. If you are liking our streams, please like our Planetarium, UTA Planetarium on Facebook, because that's where you can get connected and you can get the latest information from us, the latest posts. And also, would like to thank our team members. Currently on the control, there is Jim Bader, our program coordinator, Jennifer Jones, and Huzaira Sohail is also helping us with all the moderation and the social media help. So can a meteorite, if entering the atmosphere at a very acute angle, skip like a rock on the surface? Well, that's also possible. Well, that happens actually when we get meteorites from other planets or the moon. Sometimes we realize that found meteorite has very similarities to the moon or Mars, and then we think that we think that meteorite came from the moon or Mars. So how come that can happen? How come a chunk of rock can fly from the planet's surface and end up at Earth? So that's actually a result of a collision. So that means another space rock hit a planet or the moon, and then took chunk in free fly, and that chunk escaped the planet or the moon, and it ends up over here. And similar things happens for Earth too. We don't know how many Earth mass is actually escaping as a result of collision. But when we think about Earth, we need to first think about 75% of water coverage. So there is another cushion before a meteor hits to the surface of planets. And actually, this is a very dangerous scenario, because if a meteor is just large enough to reach to the surface of the planet with the water cushion, there's going to be a big tsunami. So let's look at some other questions. We are getting a lot of questions. That's great. Please keep asking questions. Can a meteor event be predicted based on any previous experiences? And the answer is no. Meteors are very unpredicted events because, I need to step back on that a little bit. They can come anytime at any angle. But we know that that's not a big surprise. NASA has great observatories. and satellites watching all the approaching pieces of rock. So we know ahead of time if there is a big one coming to our head. But there are also predictions, like, for example, meteor showers. We know meteor showers when it's going to happen, and actually meteor showers are some the debris fields we talked at the beginning of stream. So we know when Earth is going to enter into that debris field. And when it enters into the debris field, there is going to be likely a lot of shooting stars in the sky. So that's when we say, well, there's going to be a meteor shower in March, there's going to be another meteor shower in July, etc. So those are predicted meteor showers or meteor events. But there are also unpredicted ones. All right, so what keeps the ISS from being damaged by a meteor? Actually, nothing. The ISS, like any other satellite or a space shuttle, it is prone to damages by any type of space debris. And as we talked, by the physics law of momentum, even a smaller debris, like a dust-sized debris, because they are moving so fast, they can cause a significant damage. They, in the past, damaged satellites and knocked down the communication, and they damaged some space shuttles. And ISS, how it is avoiding? Well, there are small maneuvers that they can do if any big one comes close. But there is not really, by then just thinking that the likelihood of International Space Station by being hit by a meteor is small, because of just the dimensions of the space station versus the space around the Earth that encounters the big meteors. All right, so another question is, where is the meteor that stuck in Arizona? Well, the meteors, that something we didn't talk about, is after big impacts, because of the amount of energy dissipated, the meteors most of the time actually evaporate. They get melted. So it is similar to the event model, the computer model that they modeled for the event that killed the dinosaurs. The rock falls, hits the ground, and it is actually digging a big hole. Then, because the energy is great and a lot of heat dissipated to the surface melts, the meteor also melts. And because there's still energy in the hole, and that changes until it cools down, it changes the shape of the hole, and the meteor most of the time completely evaporates and joins to the ingredients of the hole. And sometimes we realize that the meteor craters are having a little different chemistry than Earth, and because of the meteor impact. But yeah, it is not collected. It is not collected. So let's take one more question. What meteors are the rarest, and how big a meteor can be? Well, I don't think there's any rare meteor. I'm not sure if that's related to the chemical composition, but I wished to see more like diamond-based meteors than all other matters. Yes, there are some actually asteroids in the solar system, which almost completely featuring diamond in them, which is a very valuable material. And how big can a meteorite be? So, as we said at the beginning, they are mostly pebble-sized rocks. That's what we see in the night sky as shooting stars. Sometimes they are bigger, and if they are in basketball size and larger, they can end up on Earth. And we are showing the largest one that was found in South Africa and in a place called Koba. If you look up for a Koba meteorite, you would end up seeing this. So this is the largest meteorite we found on Earth. So it is pretty large. Okay, let's take one more question. The difference between asteroid and meteor, that's a good question. So it's the same material named differently depending on its location. When a space rock is orbiting between Earth and Mars, it's called asteroids. And the same asteroid gets close to Earth and enters into the Earth's atmosphere and starts burning, and we see it in the sky, we call it meteor. Well, let's say it's large enough and it didn't burn completely, and somebody found the remainder on the surface of Earth, then it is called meteorites. So that's the same thing, 3 different names depending on their location. All right, great questions. All right, we would like to end this stream just for now, but we will be back with another stream next week. Again, if you like us, please mention that by liking our live stream or UTA Planetarium page on Facebook. And hopefully next week we will be with you again with another great topic. And keep watching our weekly night sky videos too. All right, thank you very much everyone for listening. Hope to see you all next week.